Arizona, there isn't a statewide regulation that necessitates the use of current-limiting fuses sufficient for 5K short-circuit current rating, or SCCR, in all power installations. It's crucial to understand what the short-circuit current rating represents. The short-circuit current rating is the maximum prospective short-circuit current that a component or assembly can withstand without sustaining damage. This rating is typically expressed in kiloamps, abbreviated as K. A higher SCCR indicates a greater ability to withstand the effects of a short circuit. In electrical systems, overcurrent protection devices such as fuses and circuit breakers play a vital role in protecting equipment and personnel from the harmful effects of overcurrents and short circuits. These devices are designed to interrupt the flow of current when it exceeds a predetermined level, thereby preventing damage to the system. Current-limiting fuses are a specific type of fuse that not only interrupts the flow of current during an overcurrent event, but also limits the magnitude of the fault current. This limiting action can significantly reduce the stress on downstream components and equipment, enhancing the overall safety and reliability of the electrical system. While there isn't a uniform statewide mandate in Arizona for 5K SCCR protection, it is imperative to consult with local authorities and electrical inspectors in the specific jurisdictions where power installations are being carried out. These local entities may have adopted their own codes or ordinances that impose more stringent requirements for short-circuit current protection. The National Electrical Code, abbreviated NEC, serves as a widely adopted standard for electrical installations in the United States. While the NEC itself is not law unless adopted by a particular jurisdiction, it provides comprehensive guidelines for safe and reliable electrical practices. Many states and local jurisdictions incorporate the NEC into their electrical codes, either in its entirety or with specific modifications. When working on electrical installations in Arizona, it is essential to be aware of the specific edition of the NEC that has been adopted by the local jurisdiction. The NEC undergoes revisions every 3 years, and each edition may contain updates or changes that impact the requirements for short-circuit current protection. To determine the applicable electrical codes and regulations in a specific area of Arizona, it is recommended to contact the local building department or electrical inspection authority. These entities can provide information on the adopted edition of the NEC, as well as any local amendments or ordinances that may be in effect. In addition to complying with mandatory codes and regulations, it is also considered good engineering practice to assess the short-circuit current availability at a point of installation. This assessment involves determining the maximum fault current that could potentially flow in the event of a short circuit. The short-circuit current availability is influenced by factors such as the utility power source, transformer impedance, and conductor size. Once the short-circuit current availability has been determined, the appropriate overcurrent protection devices can be selected to ensure that they have a sufficient SCCR to withstand the potential fault current. In situations where the available short-circuit current exceeds the SCCR of downstream equipment, it may be necessary to implement measures to reduce the fault current or increase the SCCR of the equipment. Current-limiting fuses can be used to reduce the magnitude of the fault current, while other techniques, such as adding impedance to the circuit, can also be employed. Moreover, when designing electrical systems, it is essential to consider the coordination of overcurrent protection devices. Coordination ensures that the overcurrent protection device closest to the fault will trip first, minimizing the extent of the outage and preventing unnecessary interruptions to other parts of the system. Proper coordination requires careful selection and setting of overcurrent protection devices, taking into account their time current characteristics. In summary, while there is no statewide requirement in Arizona mandating 5 kA SCCR current limiting fuses for all power installations, it is crucial to consult with local authorities and electrical inspectors to determine the specific requirements in the areas where the installations are being performed. Adhering to applicable codes and regulations, assessing short-circuit current availability, and implementing appropriate overcurrent protection measures are essential for ensuring the safety and reliability of electrical systems. Let us now delve a little deeper into overcurrent protection. Overcurrent protection is a fundamental aspect of electrical safety. designed to safeguard electrical circuits and equipment from damage caused by excessive current flow. Overcurrent can arise from various sources, including short circuits, overloads, and ground faults. Short circuits occur when there is an unintended low resistance path between two conductors, resulting in a rapid and uncontrolled flow of current. Overloads occur when the current flowing through a circuit exceeds its rated capacity, typically due to excessive load or malfunctioning equipment. Ground faults occur when there is an unintended path between a conductor and ground, which can also lead to excessive current flow. To protect against these overcurrent conditions, electrical systems are equipped with overcurrent protection devices such as fuses and circuit breakers. These devices are designed to interrupt the flow of current when it exceeds a predetermined level, thereby preventing damage to the system and reducing the risk of electrical hazards. Fuses are simple, yet effective, overcurrent protection devices that consist of a metal strip or wire enclosed in a protective housing. When an overcurrent occurs, the metal strip or wire melts, breaking the circuit and stopping the flow of current. Fuses are typically single-use devices and must be replaced after they have blown. Circuit breakers are more sophisticated overcurrent protection devices that use a mechanical mechanism to interrupt the flow of current. When an overcurrent occurs, the circuit breaker trips, opening the circuit and stopping the flow of current. Circuit breakers can be reset after they have tripped, making them reusable. The selection of appropriate overcurrent protection devices is crucial for ensuring the safety and reliability of electrical systems. The overcurrent protection device must be sized to protect the conductors and equipment it serves, while also allowing for normal operating currents. The interrupting rating of the overcurrent protection device must also be sufficient to interrupt the maximum available fault current at the point of installation. The National Electrical Code (NEC) provides detailed guidelines for the selection and installation of overcurrent protection devices. The NEC specifies the types of overcurrent protection devices that are permitted for various applications, as well as the requirements for their sizing and interrupting rating. It is essential to consult the NEC and other applicable codes and standards when designing and installing electrical systems to ensure that adequate overcurrent protection is provided. In addition to fuses and circuit breakers, other types of overcurrent protection devices are also available, such as ground fault circuit interrupters, abbreviated GFCIs, and arc fault circuit interrupters, abbreviated ASIs. Ground fault circuit interrupters are designed to protect against ground faults, which can occur when there is an unintended path between a conductor and ground. Ground fault circuit interrupters work by monitoring the current balance between the hot and neutral conductors in a circuit. If there is a difference in current, it indicates that current is leaking to ground, and the ground fault circuit interrupter will trip, interrupting the circuit and preventing electrical shock. Arc fault circuit interrupters are designed to protect against arc faults, which can occur when there is an unintended arc between two conductors. Arc faults can be caused by damaged insulation, loose connections, or other factors. Arc fault circuit interrupters work by detecting the unique characteristics of arc faults, such as the irregular current waveforms and high-frequency noise. When an arc fault is detected, the arc fault circuit interrupter will trip, interrupting the circuit and preventing electrical fires. Ground fault circuit interrupters and arc fault circuit interrupters are often required in specific locations, such as bathrooms, kitchens, and bedrooms, to provide enhanced protection against electrical hazards. The NEC specifies the locations where ground fault circuit interrupters and arc fault circuit interrupters are required, and it is essential to comply with these requirements to ensure the safety of occupants. Proper overcurrent protection is essential for the safety and reliability of electrical systems. By selecting and installing appropriate overcurrent protection devices, electrical systems can be protected from damage caused by overcurrent conditions, and the risk of electrical hazards can be significantly reduced. Always consult with qualified electrical professionals to ensure that overcurrent protection is properly designed and installed. Now, let us consider what to do if a local electrical inspector requires something beyond the NEC. In situations where a local electrical inspector requires something beyond the National Electrical Code (NEC), it's crucial to address the situation systematically and professionally. The NEC serves as a widely adopted standard for electrical installations, but local jurisdictions often have the authority to amend or supplement it with their own requirements. These local amendments can be more stringent than the NEC or address specific local conditions. Firstly, it is important to understand the exact nature of the inspector's requirement. Request a written explanation of the specific code section or ordinance that mandates the additional requirement. This documentation will provide a clear understanding of the basis for the inspector's decision. Secondly, review the local electrical codes and ordinances to verify the inspector's interpretation. It is possible that there may be a misunderstanding or misapplication of the code. If the code is unclear or ambiguous, seek clarification from the local building department or electrical inspection authority. Thirdly, if you believe that the inspector's requirement is not justified or is unduly burdensome, you have the right to appeal the decision. The appeals process typically involves submitting a written appeal to a higher authority within the local government, such as the building official or a board of appeals. In your appeal, clearly state the reasons why you believe the inspector's requirement is not warranted, providing supporting documentation such as the NEC industry standards or engineering calculations. Fourthly, consider seeking the assistance of a qualified electrical engineer or consultant. An experienced electrical professional can review the situation, provide expert advice, and represent your interests during the appeals process. An electrical engineer can also perform calculations or studies to demonstrate that the proposed installation meets the intent of the code, even if it does not strictly comply with the inspector's interpretation. Fifthly, maintain open and respectful communication with the electrical inspector throughout the process. While it is important to advocate for your position, it is also essential to maintain a professional and courteous demeanor. A collaborative approach can often lead to a mutually acceptable resolution. Sixthly, if all other avenues have been exhausted, consider seeking legal counsel. An attorney specializing in construction law can advise you on your legal rights and options. Legal action should be considered as a last resort, as it can be costly and time-consuming. Ultimately, the goal is to ensure that the electrical installation is safe and compliant with all applicable codes and regulations. While it is important to challenge unreasonable or unjustified requirements, it is also essential to prioritize safety and to work cooperatively with the electrical inspector to achieve a satisfactory outcome. Now, to reinforce this a bit, remember these key points. Firstly, document everything. Keep detailed records of all communications, code interpretations, and supporting documentation. This documentation will be essential if you need to appeal the inspector's decision. Secondly, know your rights. Familiarize yourself with the local codes and ordinances, as well as your rights as a property owner or contractor. Thirdly, seek expert advice. Do not hesitate to consult with qualified electrical professionals or legal counsel if you are unsure of your rights or options. Fourthly, be persistent. Do not give up easily if you believe that the inspector's requirement is not justified. Pursue all available avenues of appeal until you reach a satisfactory resolution. Fifthly, prioritize safety. Always prioritize safety and ensure that the electrical installation is safe and compliant with all applicable codes and regulations.